wanted to talk to you today because we've seen yesterday how big data is really exploding. Data, as it gets bigger, gets this sort of network effect, and we can get emerging properties and find out really interesting information from it. And we hear a lot about big data, but we don't hear a lot about semantic web, which is kind of strange because you would think with linked open data, that's the biggest possible of big data. It's extreme. And I think one of the reasons is that people have been locked out, the general public have been locked out of it. And it's not like they don't want to get that information. So, 96%, I think it is, of Wikipedia or Google search results have Wikipedia in the first results. And it's because people are looking for information. They're looking for book author names. They're looking for music, their favorite films, people, companies, products. They're constantly searching for information. But again, they've been generally locked out. SPARQL is just simply too technical for most people. And it started us thinking about, well, what if there was a better way, a different way to sort of index that information and get it out there in a way that people could consume better. So, the foundation of Brodlist was really, could we redefine our triples? Could we eliminate the necessity of having joins? And could we put it all on a really fast key value store? And so when I say redefine our triples and joins, what would that look like? And so here's an example I took from SQL, but you can imagine SPARQL here as well. So for here, what we're looking at is taking employee accounts, and we only want to do it for departments where it's the sales department. So you can see the SQL statement for that. And it's pretty complex, and it's pretty hard for a normal person to put together. And SPARQL is no different from that. And the foundation of Brodlist is based on the idea of changing that syntax, changing how the representation is stored so that you can say something like employee.accounts, so employees' accounts, where the department name is sales. And simply state it like that. You can do it over HTTP, a GET request, just like that, and get back the information you're looking for in JSON. And so that's the foundation of Brodlist. And what's interesting, I think, is that simplicity sort of sublimates up into the UI. And so now what you can do is, instead of typing some really complex request, the video here, I'm going to walk you through what it would look like to, if you wanted to say, fine, you're in Paris and you enjoy Picasso, and what you'd like to do is see which museums you have to go to find Picasso artworks. So we'll start off and we'll type in museum, and that will get us a list of all museums in the world. And now we'll type in Paris, but we don't want the Greek mythology character, we want Paris, France. And so now that's reduced it to just the 150 or so museums in Paris. Now if we type in Picasso and select Pablo Picasso from the list, it's going to look at for those museums which have the artworks of the artist Pablo Picasso. And then we can just click on the map and see where those handful of museums with Picassos are. So that's a very quick run through of one type of search. But the idea behind this is that it can then kick off knowledge engineering. And that's something really exciting. It's been locked out, included for a lot of people that are interested in getting that information, in using the semantic web. They've just been locked out completely. I can go over the technical architecture really quickly. I think it's a little bit interesting. The main server is on the left, and that's done with C++ and Tokyo Cabinet backend key value store. It's all, again, everything is done RESTfully. So when they make a request, it goes out and does the full query on that server. But there are also additional sort of helper systems. One is when you type in, you want Picasso, when you type in PIC, it goes out and it goes through using Node.js and React. And that's on the far right. And it brings you back the list of those prompts that you might expect if you type in, you start with Picasso and other variations that start with those letters. And the third system here that I want to show is when this main server sends back results. So when you go to the query on the far left, and it will return it just row IDs. So what it has to do then is go asynchronously out to another server and get the information for each one of those rows. And it will actually cache those in HTML5 local storage locally. And so those are the three basic systems that are at work here. So to summarize, and I've gone really fast, I'm sorry, I expected that to take much longer. The idea is to open up the semantic web, allow people to do knowledge engineering, asking questions they've really been precluded from asking before. It's free for the public, it's usable by everyone, and that's it.